Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to improve our math skill. Today is our day number 22. Let's see what we have for today. Just 1 second, just give me 1 second here. I forgot to turn my fan on. I'm still here. There we go. Get some air circulation going here. There we go. Today is our day number 22. Here's a question. Machine A does the job in 7 hours. In 7 hours. Machine B does the same job in only 5 hours. The question simply is, approximately how long? Well, you can probably guess by now where this is going. Approximately how long it takes for machine A and B to do the job working simultaneously. In other words, A and B are working together at the same time doing the job. Question simply is, if one machine takes 7 hours to finish a certain job and the other machine takes 5 hours to do the same job, how long will it take for them to finish the job if they are working together? And here are your answer choices. Approximately how long will it take for them to finish the job? And the answer choices are there you go. What I want you to do now, as always, and if I forget to remind you this thing, you should do it always on your own. Never watch the solution to the problem in its entirety without actually having tried the solution yourself, because that's where the fun part is. You will learn more even if you have trouble solving it, and even if it turns out that the answer that you came up with was the wrong answer. Trust me, you will actually learn more by having done the problem yourself, even if it is wrong, than watching somebody else do the problem correctly for the very first time. To begin with, what I meant to say. So pause the video, solve it yourself. When you have the answer, then you can resume it. Okay? I'll give you a few seconds to pause it and start it. There are two ways. Had it been a real exam, you should realize that there are two ways that you can solve this problem. Because this is a multiple choice exam, there are two ways you can attack this problem. One is what I call the conventional way, the traditional way, the orthodox way, the classical way, the geeky way, the nerdy way, the academic way, the mathematical way, the proper way, the way your math teacher will expect you to solve this problem. That's one way. Very traditional way, very orthodox way, very classical way. And there is another way, which I refer to as, for the lack of better terminology, as the quick and dirty way. well, it's not for the lack of better terminology, because well, I like quick and dirty. Why not? Which way should we do first? Let's do quick and dirty first. Why not? The quick and dirty way, whenever you solve a problem in that manner, you always must keep in mind that there is no guarantee that you will find the right answer in the quick and dirty way. But in the worst case scenario, even if you do it quick and dirty way, in the worst case scenario, you should be able to eliminate at least 1 or 2 answer choices, perhaps even 3 answer choices. And if you can eliminate 1 or 2 or 3 answer choices, so you're down to 2, 50-50 chance. 50-50 chance in the exam is not a bad odd if either you do not have the time to solve it properly or you do not know how to solve it properly. In either case, if you're lacking the algebraic skill, if your skills in algebra are not up to par, or you are very good in algebra but you simply don't have the time to solve it properly, time is running out, there's only 2 minutes left in the clock and you got 3 more questions to go. You don't have the luxury of solving it properly. In that scenario, the way to go about it is to make an intelligent guess. Making intelligent guess comes from being able to do what I call quick and dirty thinking. Dirty because some people think that it's somehow cheating. It's not. It's dirty in the sense that you're not doing the actual work that you're supposed to do. So what? Nobody looks at your work in the exam. It's a multiple choice exam, computerized exam. Nobody looks at your work. That's it. Nobody's going to give you credit for doing the work properly. Anyway, enough of the talk. Let's do it here. The quick and dirty way first. And then we'll do the conventional way. Well, what you should realize is that if they are working together, they should take maximum of, before I put down what number I'm about to put down, what I'm trying to make you understand is that in a problem such as this one, it's always a good idea to establish a range in your mind based on rational thinking, obviously, not based on some wild thinking or going on the gut feeling. Based on rational thinking, you must have some idea as to what the answer choice must lie in what range, in what area, in what neighborhood. So, working together, they should take more than 2.5 hours. Now, where is that coming from? Why do we know that if these two machines are working together, they must take more than 2.5 hours? Well, here's the reason. Here's the logic behind it. Okay, follow me. Try to understand it. Follow me. We are told that one machine does the job in 5 hours. The machine that does the job in 5 hours is the faster one. Notice what I just said. It is a very common error. I hear it all the time, which annoys the hell out of me. People use the word, people use superlative is called fastest. They say the fastest one is 5 hours. It's not fastest because there are only 2, so we have to use the comparative and not the superlative. Faster, not the fastest. That was a little digression in grammar. I do not know why I have these urges, but anyway. What we have to realize is working together, they should take no more than 2.5 hours. Why is that? Because the faster machine takes 5 hours. So if I were to assume that both of these machines are equally fast, one takes 5 hours, the other one takes 7 hours, even if this machine were to take 5 hours, which is a purely hypothetical statement, even if that were the case, it's a hypothetical statement. Even if this machine did take 5 hours, same as this one, then this machine would do half the job in 2.5 hours. This machine would have done half the job in 2.5 hours. Working together, they would have finished the entire job in 2.5 hours. In other words, if you have only one machine being able to do the entire job in 5 hours, then it stands to reason that another identical machine working together should be able to finish the entire job in 2.5 hours, because one machine is doing half the job, the other one is doing the other half of the job. In other words, working together, they should take no more than 2.5 hours. No more than 2.5 hours. If you see any answer choice which is more than 2.5 hours, 2.5 hours, it is an unreasonable answer. The answer is not going to be there. Based on that logic, what can we kill? We can kill no more than 2.5 hours, which means, oh sorry, not no more than 2.5 hours. We're talking about a faster machine right now. Working together, they would take more than 2.5 hours. They would take more than 2.5 hours, because we're assuming that both machines are working equally fast, which is not the case here because one machine is slower. So because one machine is slower, we know that at the very least, whatever the amount of time they're going to take, it will have to be more than 2.5 hours, because 2.5 hours would have been the time if we had two identical machines being able to do the job in 5 hours. Alright? Which means we know that it should take more than 2.5 hours, which means I can kill A. A is gone. That's ridiculous. They're not going to be able to finish the job in 2 hours. Using the similar logic, using the exact same logic, let's look at the other part here. Working together, they should take more than 2.5 hours, but take more than 2.5 hours, but less than 3.5 hours. And where is that coming from? Well, exact same logic would apply here, but now we are assuming that we have two slow machines. If we had two slow machines being the 7 hour, then one machine can finish the job in 7 hours, and if I had the identical machine being able to finish the job in 7 hours, then one machine in 3.5 hours would do half the job, other machine will in 3.5 hours would do the other half of the job. The whole job will be finished in 3.5 hours if we had two machines both individually being able to do the job in 7 hours. Which means even in the worst case scenario, these two machines working together should not take more than 3.5 hours, because we have one slow machine, but we have one machine which is even faster than that. Which means it will take whatever it is, it's going to be less than 3.5 hours. What can we do? It will take less than 3.5 hours, which tells me that I can kill anything that is more than 3.5. Let's see, what can we kill? We can get rid of E, we can get rid of D, we can get rid of O, we can get rid of C. Oh, voila, we are done, that's it. See, I made all this fuss about it. Here we got lucky. We got the right answer, that's it. A lot of the times you'll narrow down to 50-50. You'll be left with only two answer choices. You know that it's between this and that. You cross out all the answer choices outside that range, and most of the times you can get rid of 2 or 3 answer choices by using this logic. Once in a while, if you get lucky, once in a blue moon, you're able to get rid of 4 answer choices, in which case you found the right answer without doing any work at all. So without doing any work at all in the sense of the classical work. That's it, that's the answer. The answer is 3. That's all, we're done. Now, if you're hell-bent, only if you're hell-bent, we'll do the problem the proper way. Alright, I need the room, so I'm going to erase it. I need to erase all of this thing, or better yet, perhaps I should erase the problem so we can do the classical work on the top instead of erasing this part. I'm going to erase the problem. Okay, one more time I'm going to read it. Machine A does the job in 7 hours. Machine B does the same job in 5 hours. Approximately how long will it take for machine A and B to do the job working simultaneously, working together? Now let's do the classical way, the conventional way, the geeky way, the nerdy way. Conventional method. In 1 hour, A would do 1/7 of the job. How do we know that it will do 1/7 of the job? Because it takes 7 hours to do the entire job. If I had a machine, we could do the entire job in 10 hours, then in 1 hour, that machine would do 1/10 of the job. If I had the machine who can do the entire job in 2 hours, then in 1 hour it will do half the job, 1/2. If I had the machine which can do the job in 3 hours, then in 1 hour it will do 1/3 of the work, 1/3. Here we have 7 hours, it can do the entire job in 7 hours, which means in 1 hour it will do 1/7 of a job, which makes sense because 7/7 7/7 will give you the entire job. Similarly, in 1 hour, B would do 1/5 of the job. Therefore, working together, this symbol means therefore, working together, I shouldn't have put all this here because I'm very crowded here. Working together, I may actually end up erasing it. Working together in 1 hour, they would do, now I need the room so I do have to erase it. I was going to leave it there so we can compare the two, but I need the room. Working together they would do 1/7 plus 1/5 of the job in 1 hour. Let's simplify this thing. So the common denominator is 35. We have 5 plus 7, which is 12 over 35. 12 over 35. This is in 1 hour. Therefore, again, for those of you who do not know it, this symbol means therefore. If you see a symbol like this, 2 dots on the top and 1 on the bottom, that means since. Since as in logic, not as in time. This symbol does not mean since 3 o'clock, it means since he is older than, since A costs more than B and B costs more than C, therefore A costs more than C. You get the idea. Since as in logic. Therefore, working together, they would finish the entire job in 35 over 12 hours, which is approximately 3 hours. That's it. Working together, they would finish the entire job in 35 over 12 hours, which is approximately 3 hours, which is exactly what we found here. Now I'm going to erase all these things so that it's not very crowded, so I can explain to you one last thing that I did here in a hurry. You see? Let me explain you here. If you find that you have a machine which can do a third of a job in 1 hour, then in 2 hours it will do 2/3 of the job, and in 3 hours it will do the entire job. So whole job, let's put it here. In 1 hour, and this is the whole job. So if you have the machine that can do, a third of a job in 1 hour, then in 2 hours it will do 2/3 of the job, and in 3 hours it will do the entire job. Where is the 3 coming from? It's the reciprocal of this. 1 over 3, it gives 3 over 1 is the whole job. That's how long it will take to do the whole job. Whole job, hours for the whole job. Hours for the whole job. This is 1 hour. If you had a machine that did half the work in 1 hour, then it will take 2 hours to finish the job. Where is the 2 coming from? 2 over 1. If we had a machine that did 1/10 of a job in 1 hour, then in 10 hours it should be able to finish the job because it's doing 1/10 of a job in 1 hour. Where is the 10 coming from? It's 10 over 1. The same exact thing is going on here. Here, in 1 hour, we can do this much work. 12 over 35. Which means the entire job should take 35 over 12. That's how we get 35 over 12. And we know that 36 over 12 is 3, therefore it's little under 3. And since they're asking for approximately, hence the use of the word, oh I erased it, I was going to underline, circle the approximately. There you go, approximately. Approximately 3 hours. That's it. Which of course, we didn't have to go through all this fuss here. We could have approximated the 3 hours here. Watch this. I'm going to do it in green color. So in 1 hour is this much. This is the 1 hour part. We could have done our approximation right here by saying that 12 over 35 is same as 1 over 3. Approximately 1/3. Because 12 over 36 is 3. Had it been 12 over 36, it would have been 1/3. So this is approximately 1/3. So if the machine can do the job, if the machine can do 1/3 of the job in 1 hour, in 3 hours it will finish the job. That's what it is. That's the answer. That's it. We're done. I think I explained way too much. Sometimes I have a tendency of doing that, and I just never know when to quit. I hope it was helpful. I hope it wasn't too much explanation. But that's what you need to do in the work. These are called work problem, where they give you one machine is this much and one other machine is that much. Before you do any work at all, always ask yourself, what is the logical range here? The logical range will fall between, assuming all the machines are working at the slowest pace. If I give you 3 machines, one is finishing the job in 4 hours, one is finishing the job in 5 hours, the other machine is finishing in 10 hours. That's the slowest one, which means that if every machine was working at the slowest pace, well, if it's finishing in 10 hours, then 3 of them working at the same pace should be able to finish the job in 3 1/3 hours. So that's your 1 point in the range. And then the fastest machine, I forgot what I told you, if the fastest machine is finishing a job in 2 hours, or in 3 hours let's say, if fastest machine is finishing a job in 3 hours, and if you have 3 machines there, then all the machines working at the fastest pace should be able to do the job in 1 hour. So there is your range. Between 1 and, I forgot the other one. Okay, but you get the idea. Always establish the range. That's what we did here in the quick and dirty way. We had 2 machines. If both machines are able to do the fifth of the job, if both machines are able to do the job in 5 hours, then working together at the same pace, they should be able to finish the job in 2.5 hours. That's your 1 point in the range. If both machines were working at the slow pace, at 7 hours to do the job, then working together they should take no more than 3.5 hours. So there is your range between 2.5 and 3.5. How many answer choices do you see here that fall between 2.5 and 3.5? Only one. There was nothing to do. I wouldn't sit there and do all this work in the exam. I wouldn't. That's the answer is right there. You just have to think logically. That's all. Alright? Anyway, if you wish to get hold of me for personal private tutoring, I provide math tutoring for any math subject at all, algebra, geometry, statistics, and I also of course do private tutoring for the prep courses for GRE, GMAT, SAT and TOEFL. Just go to any of these website addresses and send me an email. Or you can simply go to ishwaniprep.com and get hold of me from there as well. Okay? Thanks.